Okay guys, welcome to the Integrated Math 3 Fall Final Exam Review. Let's go ahead and get started because this might be a pretty long review. There's a lot of stuff to cover. Okay, so let's start with number 1. Alright, number 1 says solve, and there's an part A, part B. 3x squared equals negative x plus 2. This is a quadratic equation. There's only two ways actually that we talked about of how to solve these equations, is to put it in standard form. So let's start with that. I am going to add x to both sides. And you know what? I'm going to take care of the 2 also. So I'm going to subtract 2 from both sides to take care of that. Now I'm going to do it over here as well. Now these cancel, and so I'm left with 0 on the right side. On the left, I get 3x squared plus x minus 2. Next, what I'm going to try to do is try to factor this quadratic right here. Okay? If factoring doesn't work, then I go to the quadratic formula. That's the only way that I know how to solve these equations, right? Factoring or quadratic formula. So let's try to factor. Let's see. 3 times negative 2 is negative 6. And the number in the middle is b, which is 1. Two numbers that multiply to make negative 6 and combine together to make 1. I think 3 and 2 have to be involved. And I think the 2 must be negative. Right? 3 times negative 2 is negative 6. 3 minus 2 is 1. There you go. That's it. So it's going to be 3x squared plus 3x minus 2x minus 2. Don't forget that the 3x and the negative 2x right here is basically this one. It got split up into two pieces based on these two numbers. Right? 3x minus 2x is x. So I basically took the middle term and split it up based on these two numbers that I found with the x here. Alright, now what I'm going to do is group them up. I'm going to group these two together. I'm going to group these two together and see if I can find their GCF. For the first pair, I know that they both have a 3 in common and an x. So I'm going to divide by 3x. That means that I have 3x, and then inside what will be left is x plus 1. Not 0, which is what a lot of you guys do. You cancel these and you say, oh, there's nothing left, so it's just x. No, it's 1 because you're dividing, right? For the other pair, I notice that the first term is negative, so I have to divide by negative. Right? That is a requirement. Also, they both have a 2 in common, so divide by negative 2. So I'm going to factor out negative 2, and what's left is x plus 1 equals 0. Don't forget that this whole time it's equal to 0. Now I can see that the x plus 1 is what they have in common, so that is my first factor, x plus 1. And the other one is 3x minus 2 equals 0. And now I can solve those two pieces by setting them both equal to 0. So for the first one, I'm going to get x equals negative 1. This part you guys can do in your head, right? X plus 1 equals 0 means x equals negative 1. 3x minus 2 equals 0. That's a little tougher to do, but you guys can also solve that fairly quickly. 3x minus 2 equals 0 gives you x equals 2/3. Now you guys can check that. Those are the two solutions. Okay, for part B, I want you guys to go ahead and try it on your own. So pause the video right now, go ahead and try it out, and then come back and see the answer. I will have the answer for you guys in a couple of seconds. So go ahead and pause the video now. Alright, there's a correct answer. X equals 1/3 and x equals 3/2. If you did not get those answers, go back and check your work. You should have put it in standard form and then try to factor it. My hint for this one is before you start using x factor to factor this out, notice that they're all divisible by 2. So make sure you divide by 2, everything by 2 first, and then it should become easier. Alright, let's move on to number 2. It says solve 2x squared plus 3x equals 3. Just in like in the last few examples, I am going to write it in standard form. So what I'm going to do is I'm going to subtract 3 from both sides. So I can cancel it on the right side and I'm going to get 0. On the left side, I'm going to get 2x squared plus 3x minus 3. And now what I'm going to try to do is try to do the same thing that I did in the last couple of examples, is try to do the x factor, see if I can factor these two out. So if I factor here, 2 times negative 3 is negative 6, and b is 3. So two numbers that you multiply to make negative 6, and they combine together to make 3. And after much trial and error, you should realize that nothing works. So that only leaves us with one option, which is our favorite, the quadratic formula. Okay, so we're going to use the quadratic formula to try to solve this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops, I just messed up right there. Let's try that again. 2a. What do you think that's funny? Okay. Alright, so now what we're going to do is plug in the numbers. A is 2, B is 3, and C is negative 3. So we're going to plug in those three numbers into our quadratic formula. So it's going to look like this. Here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in, b is 3, so we're going to plug in 3 right here. Also here, a is 2, c is negative 3, and a is 2. Alright, and now we're going to simplify this. X equals negative 3 plus or minus the square root of 9, 3 squared, minus 4 times 2 times negative 3. You can go ahead and multiply these out already. 4 times 2 times 3 is 8 times 3 is 24. But it's a negative times a positive times a negative, so it's going to be positive 24 plus 24. All over 2 times 2, which is 4. We're going to keep going and simplify this even further, so it's going to be negative 3 plus or minus the square root of 33. Right? Yes, 33. All over 4. And it looks like we are done. Okay, you should always try to simplify this, okay, to see if you can break anything out. But it's 33, so if you do a factor tree for 33, the only two numbers are 3 and 11. And then there's nothing else. So there's not going to be any pairs or buddies to break out. So that's it. There's nothing else to do on that one. We're going to write it as two separate answers, because remember, when we write the plus or minus here, that means there are two possibilities. So the two answers are, the two solutions are x equals negative 3 plus radical 33 over 4, and x equals negative 3, let me fix that again, negative 3 minus radical 33 over 4. There you go. Alright, so just like in the last example, I want you guys to try out part B on your own first. Okay, so go ahead and try it. You probably will need the quadratic formula for this one again, and then come back and check your answer. Okay, go ahead and pause the video now so you can do it on your own. Alright, so here's the solution to part B. I split it up into two pieces right here. Notice that I got plus or minus right here, so I split it up into plus or minus. Also notice that when I got to this point, negative 6 plus or minus radical 12 over 6, I simplified the radical 12. And you simplify that by making a factor tree. Okay, basically what I did is I set up 12, and I said, oh, that's 4 times 3. 3 is done. 2 times 2. So I have two 2's and a 3. So what happened is that these 2's got together, break out. One makes it, the other one dies. And the single 3 stayed in jail. So that's why it's 2 radical 3 right here. The 2 made out, the 3 stayed inside. And then what I did is I noticed that the number here in front are all divisible by 2. So I divided them all by 2. Okay, kind of like a little heart right here. Those all divide by 2. So it's negative 3 plus or minus 1 radical 3 all over 3. Which is this, but I split them up into positive and negative. Right, number 3, find the zeros / roots for the functions. Determine whether the graph is tangent or crosses at the x-axis at each 0 or root. Then graph. Hint, use the leading coefficient test. Okay, so let's start with A. We have f of x equals negative x plus 2 times x minus 3 times x plus 1. Okay, first thing I'm going to do is figure out what the leading coefficient is. Okay, this is right here a negative 1. So what I have is negative 1 times x times x times x, right? Basically, the leading coefficient is going to come from the first term of each of these binomials. X times x times x is x cubed, so my leading coefficient is negative x cubed. Alright, now I know what the end behavior is going to be. Since the leading coefficient is negative, and my power is x to the third, my term here is negative x to the third. Since this number is negative, that means that it's going to go down on the right side. Remember what I said? The a value tells you exactly what's happening on the right side of the graph. This one's going down. The power right here tells you if it's even that both sides are the same thing, right? If this one's down, this one's down. If that one's up, this one's up. Or if it's odd, it tells you that they're exact opposites. So if one's going down, the other one must be going up. So in this case, since this is odd, that means that the left side must be going up. There must be opposites of each other. Alright, that's going to help me a lot when it comes to solving it. Also, what I'm going to do is find the zeros. That's pretty easy for you guys. This one's going to give me negative 2. Right? This one's going to give me 3. And this one's going to give me negative 1. So that's where I'm going to place my first 3 points. Negative 2 right here. 3 right here. And negative 1 right here. Well, they're all pretty close together. I also know that on the right side it's going down and on the left side it's going up. So that's pretty safe to draw those arrows there. Next, check if they're supposed to be crossing or tangent. To check that, all you care about is what the exponent here is, right? What is the multiplicity, basically? What is the degree of each of these zeros? This one is just 1, this one is just 1, this one is just 1. All of them are odd. So if they're all odd, that means that it's going to be crossing at each of these points. It's going to cross this way, come back up, cross again. No tangents in this case. And that's it. Okay, I want you guys to try part B on your own. So just like before, go ahead and try it on your own and then come back and check your answer. So go ahead and pause the video right now so you can check it. Alright, here you go. I started by finding the zeros, which this one gives you 0, this one gives you 2, and this one gives you negative 1. I also figured out that since this one, the degree is 2, that means it's tangent, right? The power is even, that's tangent. Odd crosses, odd crosses. Remember when we said even and odd, we're not talking about the actual number of the 0, but the power of it, okay? The power here is 1, the power here is 1, so they're both odd, they cross. Also found the leading coefficient, the leading term, which is x to the 4th. X squared times x, x to the 4th. That means that since it's positive, it's going up on the right side. And since this is even, that means that they're both the same. So up and up. And so it goes this way and then around and this way because it's supposed to cross at negative 1. It's supposed to be tangent at 0, so that's why it just touches it and comes back down. And then cross again through 2. Alright, I'm going to skip number 4. I feel like you guys can handle it. Also number 5, it's just multiplying, it's just adding. For number 4, all it's asking you is to tell, after you do the calculation, if it's supposed to be quadratic, linear, or cubic. So just check what your leading term is, what your highest degree is. If you see an x cubed, then it's cubic. If you see an x squared, then it's quadratic. If you see x, then it's linear. Okay. If you see no x as just constants, like 4, 5, 6, whatever, it's still linear. Okay, it's a linear equation because it still creates a straight line. Right, number 6, divide each using synthetic division. So let's practice this one a little bit. I'm going to set it up for synthetic division by putting a little box right here. The terms are 1, negative 8, and 6. Always make sure you check for any missing terms, which means that you would place a 0 there. This one's not missing anything. So you're going to write 1, negative 8, 6. The only confusion that people get is what am I supposed to put in the box if I'm dividing by x plus 2. Remember, this dividing by x plus 2 means that you're trying to solve it. You're trying to check if this is a solution. So what the actual solution would be, if you were to solve this equal to 0, would be negative 2. So the number that goes in here is negative 2. Okay? Which is also like saying, what happens when I plug in negative 2 into this equation, right? Synthetic substitution. Let's do it. Bring down the 1. Negative 2 times 1 is negative 2. Negative 8 and negative 2 make negative 10. Again, multiply. Negative 2 times negative 10 is positive 20. So you put a 20 here. 20 plus 6 is 26. Done. It says of the instructions, determine whether the divisor is a factor. you check after you did the work, you check the remainder, which is 26. Since I got a remainder, then this is not a factor. Okay? If this was 0, that means that there's no remainder, in which means that this is a factor. So in this case, x plus 2 is not a factor. All right, go ahead and try part B, on your own. It should be also pretty easy to work out. It's just one extra term than the one I just did, but go ahead and try it on your own. Pause the video right now so you can come back and check what the correct answer is. Okay, go ahead and pause now. All right, so here's the answer for part B. You can see my work right there. Hopefully everything's correct. The point of this is here, right here, we got a remainder of negative 217, which means that this x minus 3 is not a factor. Also, make sure you remember that if it's divided by x minus 3, the number you place here is 3. Let's move on to number 7. Here we go. Let's start with A. Divide by using long division. So no synthetic, long division in this case. So what I'm going to do is set it up for long division by writing the 2x cubed plus 14x squared minus 4x minus 48. It doesn't seem to be missing anything, but double check. X cubed, x squared, x constant. It looks good. You know what? Let's write it a little bit lower because I'm going to need space above it, right? So I'm going to write it down here. 2x cubed plus 14x squared minus 4x minus 48. And we are dividing by 2x plus 4. Alright, first question is, what do you multiply 2x times to make 2x cubed? You have the 2 already, all you need is the x squared, right? So multiply by x squared. That's the first one. You take that x squared, you multiply times both of these and write them down here. So x squared times 2x, that's 2x cubed. That's exactly what we wanted. X squared times 4 is 4x squared. That goes here. And then you're going to subtract. Don't forget, you're always subtracting there. So when we subtract, 2x cubed minus 2x cubed cancels. 14x squared minus 4, 14 minus 4 is 10. 10x squared. Bring down the next term, which is negative 4x. Alright, we do it again. 2x times what gives you 10x squared? And that will be 5x, right? So plus 5x. 5x times 2x is 10x squared. That's what goes down there. 5x times 4 is 20x. So put a 20x on the next one. And now we're going to subtract again. 10x squared minus 10x squared cancels. Negative 4x minus 20x is negative 24x. Alright, next we're going to bring down the negative 48, which is the last term there. So this should be our last multiplication. 2x times what gives you negative 24x? That should be negative 12, right? So minus 12 right here. Multiply the negative 12 times both of them. That's negative 24x. And negative 12 times positive 4 is negative 48. Oh, look at that. We're going to subtract that. That cancels because it's negative 24 minus negative 24. And that also cancels because it's negative 48 minus negative 48. So there's no remainder. It's 0. That means that 2x plus 4 is a factor of this. There's no remainder. It fits into it perfectly. So it's x squared plus 5x minus 12 is your solution. That is your solution. No remainder. Alright, let's do the same thing as before. Go ahead and try it on your own and then come back and see what the correct answer is going to be. Okay, go ahead and pause the video now. Try it on your own. Okay, so here you go. The only thing you got to watch out for this one, and that I noticed when I was going through the work, is that right here at this point, 27 minus 27 and negative 9 minus negative 9 cancels out. So you bring down the 15x, and at the same time you should bring down the 4, okay? Because if you just leave the 15x here, you're going to have to multiply by 5, not 5x, just 5. 5 times 3x is 15x, and you have to multiply 5 times negative 1, which is negative 5. So it helps if you just go ahead and bring down the 4 already, and you don't have to do it later, okay? And then that's it. 4 minus negative 5 gives you the 9, and that is the remainder that you have. So my solution is 4x cubed plus 9x squared plus 5 plus my remainder 9 over the divisor here, which is 3x minus 1, right? The remainder over divisor like that. And it's being added to the quotient that we got. Let's look at number 8. Tell whether each statement is true or false. R is x plus 1. S is p of x, which is x squared minus 2x minus 3. Question 1. If p of 1, alright, let's figure out what that means first. P of 1. That means that they took this function here, p of x, and they plugged in 1. And so it's saying p of 1 is 0. That means they plugged in 1 and they got 0. Then that means that r is a factor of s. That means that this is a factor of that. The answer to that is no. Not necessarily. It could be, but not necessarily. Because if I plug in 1 right here and I get 0, that means that the factor that I want is not x plus 1, but x minus 1. Right? X minus 1 would be the factor. So no. If this is a factor of that, then what happens when I plug in negative 1, then I get 0, right? Because when this is a factor, it's the same thing as doing synthetic division by negative 1 and getting 0. That means that this is a factor, which is part B. If p of negative 1 equals 0, then r is a factor. Yes. Actually, it says true or false, and I'm writing yes or no, but it's the same thing. First one false, second one true. C. Synthetic substitution can be used to determine if r is a factor of s. True. The requirement for synthetic substitution is that you have a linear, that you're dividing by a linear factor, and that the first coefficient is 1, which it is, so it works. Yes, you can use synthetic substitution. Alright, let's look at number 9. Find the inverse function for each function. So I'm going to go ahead and work on A to start, and then we'll look at B and C afterwards. It says f of x equals 3x minus 5, so we're looking for the inverse. First thing I'm going to do is change f of x to y. Y equals 3x minus 5. Next, what I'm going to do is try to isolate the x. I want the x to be all by itself, so I'm going to kick out the 5 first. Add 5. That cancels, so I get y plus 5 on the left equals 3x on the right. I'm going to divide by 3. I'm going to divide that side by 3. You know what? I'm going to switch the x to the left side. So on the right side, I have y plus 5 over 3. Next, I'm going to do the switch. Finally, with the inverse means that I switch the x with the y, right? So let's do that. Y equals x plus 5 over 3. And change that y to f inverse. F inverse of x equals x plus 5 over 3. And you're done. You could leave it like that. You could also write it in this form. F inverse of x equals 1 over 3x plus 5 over 3. All I did there is share that dividing by 3 with both of them. So it's x over 3, 5 over 3. But x over 3 really means 1x over 3, so it's 1/3 x plus 5 over 3. There you go. Okay, I'm going to let you guys try B and C. They look a little bit more challenging, but really the idea is the same. Okay, so go ahead and try them on your own. Pause the video to try them first, and then come back and see what the answers are. Alright, here you go. Here's part B and part C. In part B, I decided to go ahead and multiply both sides by 4. I felt like that was the fastest way to get rid of this fraction right here. So it's 4y and then 3x minus 2. And then after that, it's pretty simple to isolate the x. I ended up with y equals 4x plus 2, of course changing it to f inverse. And I wrote it in this form, and also by sharing the 3 with both of the terms on the numerator, it's 4 over 3x plus 2/3. In C, I first added the 4 to this side, so I got y plus 4 equals 3/8 x. Then I eliminated the 3/8 one at a time. So I could have done the reciprocal, which is 8/3, but I decided to multiply times 8 first, which is cancels the 8. And on this side, all I have left is 3x. And on this side, it would be 8y plus 32. Then I divide it by 3. And so I got 8y plus 32 over 3. Changing the x with the y, it's 8x plus 32 over 3. Made it with f inverse. I left it in this form here, and then in this over here, I shared the 3 with both terms in the numerator. 8 over 3x plus 32 over 3. Alright, let's move on to number 10, factoring. Let's start with A. 12x squared y squared plus 2x y squared minus 4y squared. In all factoring problems, the first thing you should look for is a GCF. In this case, I very clearly see that they all have a 2 in common, but also y squared. They all have y squared. So factor it out. So it's going to be 2y squared outside, and then what's left inside? For the first one, it's just 6x squared. The middle term will be just x, because look, the 2 and the y squareds cancel. They go out. They go out. So it's just x. For the final term, it's going to be negative 2. That's it. Now what I'm going to try to do is factor this. Okay, so for now, I am going to ignore this one. It's still there. I know it's there. But I want to focus on the middle term instead. Okay, so we're focusing on this right here. 6x squared plus x minus 2. I'm going to see if I can x factor. 6 times negative 2 is negative 12. Two terms that, no, in the middle term is 1. Two terms that add up to 1 but multiply to make negative 12 are, there has to be a 4 and a 3 involved. Which one's negative? The 3. 4 times negative 3 is negative 12. 4 minus 3 is 1. There you go. So that means that I have 6x squared plus 4x minus 3x minus 2. And now I can pair them up. Pair those two, pair those two. For the first pair, it looks like they both have a 2x in common, right? 2x, 2x. That means that I'm going to factor out 2x, leaving me with 3x plus 2. For the other pair, they have nothing in common, but they're negative, so I'm going to factor out negative 1, right, from both of them, negative 1, negative 1. So I'm going to get 3x plus 2 again. And look at that, they have the same factor, so it's 3x plus 2 times 2x minus 1. And there's nothing left to factor there. The only thing left is to remember the stuff we left behind, the 2y squared. That goes in the front. And it's done. That's completely factored. Alright, B, x to the 4th minus 625. At first glance, you think, well, they have nothing in common. But they actually do. Okay, x to the 4th minus 625, they're both perfect squares. So I actually can use the difference. Notice that there's a subtraction sign. So we can use the difference of two squares to break it apart. The square root of x to the 4th is x squared. So x squared, x squared. The square root of 625 is 25. So plus 25 minus 25. Alright, we can't factor this right now, but we can factor this. This is, again, two perfect squares, right? A perfect square minus a perfect square. So I can keep going. X plus 5, x minus 5, right? The square root of 25 is 5. Alright, and then in front I have x squared plus 25. Usually this is enough. Okay, and it's correct if we're factoring over the reals. But if we're including imaginary numbers and imaginary solutions, we can actually keep going with this one. Because if we set it equal to 0, we're going to get x squared equals negative 25. And then we take the square root of both sides. And then we use what we know about imaginary numbers. If there's a negative inside, that means I. Also, since this is a perfect square, we can take the square root of 25, which is 5. So my answer there is plus or minus I. 5i, I mean. Because the square root of 25 is 5, and the negative makes I. So plus or minus 5i, which means that this is actually two factors, which are x plus 5i and x minus 5i. And then there's the x plus 5 and the x minus 5 that we had come up with from before, and then that's your final answer. Alright, so here's part C, 8x cubed plus 125. What I decided to do here is look at this as a perfect cube, which it is, 2 cubed. Perfect cube, perfect cube. So I use this perfect cube pattern, sum of two cubes pattern, which says that I can basically get rid of the cubes and it's just 2x plus 5. 2x plus 5. And then remember that to come up with this, you square the first one, times each other but change the sign, and square the last one. And usually we're done at this point. Okay, if this is a multiple choice question, for example, and you see this answer, then you're done. But if you don't, then that means that you probably have to keep going, which means that you need to solve this to find what the roots are for this quadratic. So what you do is you plug them all into the quadratic formula. Okay, so I plugged these numbers a, b, and c into the quadratic formula, and I ended up right here. And at that point, I noticed that the 300 can be factored, so I made a factor tree for 300. Okay, and what ended up happening is that I took out 10, I took out a 2 and a 5, and the 3 stayed inside. Also, that negative right here goes out, and it's I. So it's 10 plus or minus 10i radical 3 over 8. Then I divided the 10, the 10, and the 8 by 2 to get 5, 5, and 4. And then what I did is I rewrote both of these separate. So instead of 5 plus or minus, it's plus and minus. And I also shared the 4 with both of the terms on the numerator. So it's 5 over 4 plus 5i radical 3 over 4 and 5 over 4 minus 5i radical 3 over 4. And then once I found those roots, I put them in the factors, right? X minus, remember that, x minus. And I put that one in here and this one in here. So I came up with x minus 5 over 4 minus 5i radical 3 over 4. This one's exactly the same except for this minus becomes plus. And then over here is the 2x minus 5 that we had already come up with over there. So 2x minus 5 plus 5 is that one. And this one, after the quadratic formula and all this work, gave me these two. Alright, D 128y cubed minus 1250. The first thing I notice is that they have a GCF, which is just 2, right? Is there a bigger number that goes into both of them? No, just 2. Alright, so basically just divide both by 2. Oh, then that means that this is it. There's nothing else to do after this point. 64y cubed minus 625? Yeah. Okay. Yeah, that's it. There's really nothing else you can do because this is not a perfect cube. Oh, yes it is. It's 4 times 4 times 4. This is not a perfect cube though. That's 5 times 5 times 5 times 5. It's 5 to the 4th power. So that's a perfect cube. That's a perfect cube. This one is not a perfect cube. So that throws it off. So we can't use the difference of two cubes pattern. Alright, that means that's it. There's nothing else to do there. Alright, that's factored. Let's look at E. 6x cubed minus 2x squared minus 6x plus 2. I'm going to try, I see 4 terms, and when I see 4 terms, the first thing that comes to my mind is factoring by grouping. So I'm going to group these two together and these two together to see if that works. So for the first pair, what goes into both of them? 2x squared. Right, so factor out 2x squared, and you're going to get 3x minus 1. That's it, nothing else. For the second pair, I can divide them both by negative. Make sure you divide by negative because the first term is negative. By negative 2. And so take out the negative 2, and you are going to get 3x minus 1. Alright, so it's 3x minus 1. I notice that it's the same factor repeated, right? And the other one is 2x squared minus 2. Alright, so notice that in this one, these two have something in common, so you can factor out a 2. Okay? You know what, here's what I'm going to do so you guys can see it more clearly. That's 2x squared minus 2. I'm going to put the 3x minus 1 at the end, because there's nothing to factor. But for this pair, I can divide them both by 2. And so it's 2 times x squared minus 1. and 3x minus 1. And then, how does that help me? Now these are perfect squares, right? Perfect square minus perfect square, so I can keep going. It's x plus 1 and x minus 1 and 3x minus 1, and that's it. Hey, that one was fun. Alright, 16 is, no, F is all yours. You guys can handle that. Just use X factor. It should work out perfectly. If it doesn't, then I guess you're going to have to use quadratic formula or something, but try X factor. I think it works. Okay, go ahead and pause, come back and check your answer. Alright, there you go. There's a correct answer. 4x minus 1 times 4x minus 1, which you can write as 4x minus 1, quantity squared. 11. Identify the transformations from f of x to g of x for each function, then graph g of x. Alright, this is old, right, from the beginning of the year, but it's always helpful to review. F of x equals x squared, and then g of x is negative 2 times x minus 3 squared minus 1. So they're telling us, here's the parent function, here's the transform function, graph them both. Okay? A couple of things you have to remember from this section, which was way back at the beginning of the year. Okay? First is you got to be able to identify B, H, A, and K. And also you got to remember how we write them, in which order. B, H, A, and K. Remember how much I emphasize that you should write them in this order, because you can split them up and say the first two affect the x values, so everything they do is horizontal. The second two affect the y values, so everything they do is vertical. So if you always write it in this order, you'll always realize that those two are together, these two are together. Also, if you always write them in this order, then you'll see that you always multiply and then add or subtract. Multiply and then add or subtract. Alright, so let's figure out what these four values are for this particular situation. G of x equals negative 2 times x minus 3 squared minus 1. Alright, so this number right here in front is always the a value, right? So that's a, negative 2. Okay. Next, I see a negative 3 in here. That's h, but it's not negative 3. It's always x minus h, right? So h is 3. Next, I see a negative 1 outside. That's always k, right? K is always kicked out to the end. So k is negative 1. Alright. That means that I don't see a b. If there was a b, it would be in here next to the x, but there's nothing there. So since it's not there, you can write 1, which is true, or you can just not worry about it because it does not make a difference in your transformation. Alright, so that's the first thing you should be able to remember. Remember how to find those values in the order that we always write them in. Next, what you need to remember are the parent functions tables. So make your parent function table for this equation right here, for this one. Okay, so you do have to go back and review those. The parent function table for a quadratic, the very first one that we saw is negative 2, negative 1, 0, 1, 2, and 4, 1, 0, 1, 4. Right? And if you don't remember those numbers, remember that it's basically you can come up with it by just plugging in some numbers here to see what you get. I plug in negative 2, I got 4. Plug in negative 1, I get 1. Plug in 0, I get 0, and so on. Alright, we're going to transform those, though, into a brand new table. Here we go. Using my values here, h, a, and k, I'm going to change these numbers into something new. So according to my values, the only thing I'm doing to the x's is adding 3. That's it, because b is not there. So add 3 to all of these to see what you get. Negative 2 plus 3, that's going to give you 1. Negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Done. Next, you take these, you multiply them times negative 2, then subtract 1. All of these times negative 2, then subtract 1. 4 times negative 2 is negative 8. Minus 1 is negative 9. 1 times negative 2 is negative 2. Minus 1 is negative 3. 0 times negative 2 is 0. Minus 1 is negative 1. At that point, you can just repeat them. Notice that the next number is 1 again, so you should get the same number, and 4, you should get that same number. So it's going to be -3 and -9. And we're done. Basically, it's just a matter of graphing them now, okay? So I'm going to graph the original, the parent function in blue, like its table. So -2, 4 is up here. -1, 1 is right here. 0, 0, 1, 1, and 2, 4. Next, I'm going to graph the transformed. 1, -9. 1, -9. That one's going to be in black. 1, -9 right here. 2, -3 right here. 3, -1 right here. 4, -3 right here. 5, -9 right over here. Alright, just connect them and you're done. This is the parent function, perfect parabola that goes through the origin. The vertex is at the origin. And here's the other transform function. It's a parabola. It looks a little skinnier. Actually looks taller, which means that there was a vertical stretch. Okay, the vertex, look, it's 1, -1. I mean 3, -1, right? The vertex is 3, -1, which is basically that center point in your table. The vertex used to be 0, 0, now it's 3, -1, which comes from your h and k, right? Remember, that also comes from those two numbers. Alright, I will let you guys work on B. Same idea as before. The only thing I'm going to help you guys out with is figuring out the parent function table for x cubed, which is different. For x cubed, your table is -2, -1, 0, 1, 2, and -8, -1, 0, 1, 8. And then transform it just like we did with the last one by finding b, h, a, and k there. Okay, go for it. Okay, here you go. This is the correct solution for part B. This is the parent function table that I gave you guys. B is 1, H is -1, A is 1/2, and K equals 3. And then I went ahead and did the transformation. The blue one is the parent function. The red one is the transformed function after subtracting -1, subtracting 1 for the x values, multiplying by 1/2, and adding 3 to the y values. Okay, I believe, let me check. Identify the transformations. Yeah, that's something that we did not do in part A or part B. Identify the transformations means describe what happened. Okay, so let's go ahead and do that right now for part A, because otherwise we're going to forget. In part A, it looks like h equals 3. That means, that represents h equals 3, represents a shift to the right of 3 units. Go back and study the notes on transformations from module 5, please, so you guys can remember all these different transformations. Shift to the right 3 units. A is -2. That's two things. The negative does a reflection, the 2 makes a stretch. So let's start with the reflection. It's a reflection. Now A is vertical, so it's a vertical reflection. That means you're jumping over the x-axis, right? Vertical reflection means that you're jumping from the here over there, or from here over here. And you guys can see it from the graph. It used to be facing that way, now it's facing this way. So it's a jump over the x-axis. Reflection across the x-axis. Across x-axis. Also the 2, right? There's two things here with A. If it's negative, it's a reflection. Then the number 2 also represents a stretch. So it's a vertical stretch, because it's A, by a factor of 2. And finally, K is -1. That's a shift down by 1 unit. Down 1 unit. And if you look at the graph, exactly what we just described is what happened. Shift to the right 3 units. Here's the vertex. It's shifted to the right 3 units. Reflection across the x-axis, so the graph flipped over and started facing this way. Vertical stretch by a factor of 2, that means that the graph was grabbed and stretched vertically. That's exactly what's happening. Look, these points are pretty close together, but now they're far apart. And also shift down 1 unit, so after you shifted it to the right, now you shift it down, and that's where the new vertex is. Alright, let's describe B. In this one, we have B equals 1, which does nothing. H equals -1, that's a shift. Which direction? Left, right? Shift left. Because H does everything horizontally. Remember, B and H are horizontal. So shift left 1 unit. A is 1/2. That's a vertical compression. It's positive, so no reflection in this one. But it's a number smaller than 1, so it's a vertical compression, not stretch. Compression because it's a small number. Vertical compression. By a factor of 1/2. Factor is something that you multiply by. That's why it's by a factor of, right? You're multiplying by 1/2. Alright? And finally, K equals 3. That's a shift up. I'll just write it in red. I was going to make it in blue, but I guess I'll do it in red. Shift up 3 units. And there you go. And if you look at your graph, that's exactly what happened. From the blue one to the red one. Shift left 1 unit. Look at the center point. Shifted left 1 unit. Vertical compression by a factor of 1/2. That means that all the points got closer together vertically. They did. Look at that. It kind of shrunk. And then shift up 1 unit. So after you went left 1, you also went up 3. There's a new center point. That's exactly what happened.